All right, so yesterday, I know you're probably trying to copy that down, or I hope you are. Take a look. Yesterday we did this. All different types mixed together, right? So you've got some linear, you've got some that you have to isolate for. You know, usually you have to do a little bit of moving around. We've got just a straightforward quadratic, another quadratic, but it has reciprocal. We've got a swap out, a common factor, all different types. You have to identify the type. You have to know how to do it. It might not feel that hard yet, but trust me, as I said, people do struggle with this. They miss what type it is and do something radically wrong and make a bunch of mistakes. We're not adding a lot onto that today. On the next day, we will look at a new type. The only real difference today is one minor thing, which we'll get to in a moment. So what kind is this? Is it linear or quadratic? It's quadratic. Is there a swap out? No swap out. Everything's in terms of sign already. We've got a sine squared and a sine. Is it common factor? No, right? So it's a trinomial. So what is our first step or our next step after we've kind of diagnosed where we're at? What do we do? Huh? Discriminant b squared minus 4ac to figure out what we do, what our next step is. So go ahead and do that. What do you get? 104 is what I got as well. Anybody else get that? A couple people tried it. Good. What does that mean? Very nice. Well put as well, right? Not factorable, but you can solve it. It's not negative, which you're not going to get a negative one. That would be entirely besides the point for this unit. So it's always going to work out, okay, that you can solve it. But we can't factor, so we have to use quadratic formula. First, there's a few tricks to using quadratic formula with trig functions. You might have done this and seen this in grade 11. I don't know how much of that you do, but you may have seen it, but there's a couple of things that are a little bit different, so we have to be careful of that. The first one is, usually when we're doing quadratic formula, it's x equals, but in this case it's not. So what is it?
Sin x equals?
Yeah. Okay, and then the quadratic formula, see if you can sub in for that. I got that. You can reduce root 104. Uh-oh. My calculator doesn't want to cooperate. Oh, great. Oh, there it goes. Square root 104. Okay, so it's 4 times 26, which works out to 2 root 26. You don't have to show these steps. It is something you should be able to do for sure, like we've talked about. And I can divide 2 out of 8, 2, and 20. Remember, there's 3 things you have to divide out of all of them. If you put it into your calculator, I think that's what it would spit out at you. Okay. That's not our final answer. Generally speaking, if we were doing like polynomials or something and you were asked for exact values, then you have to know how to do that reducing of radicals. But in this case, it's not our final answer, so it doesn't really matter. You don't have to. Your calculator might spit that out at you, though, so you could use that, or you could just stick with the original. Okay, next step. Sometimes in polynomials, we sort of cheated a bit, or we were lazy, and we would just go kind of straight to the answer. In this case, we can't do that. So we have to split it up into 2 parts. And we're actually going to put both of those into the calculator and see what kind of value we get. Doesn't really matter how many decimals you keep there, because we're not going to use that rounded version anyway. We're going to use the exact value, but why would I want to do that? Why do I have to do that? Chet? Yep, very good. You could have solutions that don't exist. What else? There's another reason beyond that. To think about what quadrant it's in. What is the relevancy there? Like, what tells us about the quadrant? Anybody? The sign. Sign is negative or sign is positive. And there's one more thing. What's our next step going to be? Remember we talked about this just yesterday, how like you know how to do this. And if I gave you this question on a test, which you've seen questions like this, starting at this point, you would know what to do. But because we started from somewhere else, it's not as obvious. Go ahead, Tia. We have to do calculator. It's not exact value. It's not going to be if you do quadratic formula, right? I think you can think that through. That should be obvious. So we have to do the inverse. What do we do when we do inverse sine, in this case, of a value that's negative? Yeah, we put in the positive value. How do I put in the positive value of that? Multiply by -1. Great. There are different ways of doing it. I'm going to leave this up to you to make sure that you practice on your calculator and you figure out a way that worked for you. If you have a fancy calculator like this one, it's pretty easy. I'm going to show you what that looks like in a moment. If you don't, and you have a calculator that's more like a one-line thing, which I don't know that anybody does, but sometimes people do, and it might be a little bit harder, so you have to figure out where to put the negative. Where the brackets go, where the negative goes. There are lots of different ways to do it. But in other words, x related is going to be inverse sine of the negative of 4 minus root 26 over 10. And on this calculator, I can literally just do that. Negative fraction 4 minus root 26 over 10. And that should give me the answer. In fact, I'm going to go back and take out the sign part and just show this. So notice that gives me the same related angle, or sorry, the same value for the quadratic formula, but with a positive out front. If you don't do that, your calculator is going to give you something that you might be able to use, but it's probably going to be wrong. And again, that's not something we've talked about. What if you put a negative value in when you do the inverse of sine or cos? What does that mean? It's not something we've talked about. And it's not worth getting into. The better thing is to know how to get rid of the negative. So that's one way of doing it. Or do this, which is negative, and then just go times -1, which gives you the positive version of it, and then go shift sign of your answer equals. Same thing. Like you could do it in steps, or you could, like I said, do it, where did I find, there it is, all at once by putting a negative out in front. Or if you're using brackets, the negative has to be outside the brackets. Or you put the negative on the 10 in the denominator. That would do it, right? That will flip the sign of everything. So there's lots of different ways, shortcuts maybe that you could use depending on your calculator. Make sure you know how to do it. Make sure you're careful. This is the only tricky thing for these with quadratic formula, is watching out for that negative and knowing that you can't just take what you have here and shove it into your calculator you got to check first to see what it is. In the end, though, we're not actually going to use that. We are going to use the exact value. Okay. So that works out to 6.3097. And then what? That doesn't look right. Oh, I wonder if this isn't in the right mode. Did you get that, or did you get something else? Yeah, that sounds right. I don't know what's wrong with mine. There we go. I was in the wrong. I was in degrees. I forgot I rebooted. 0, 1. There we go. That's what you got? Okay. And then, what do we do? What's next? Jet, you already said this before. Yeah, we kind of checked that. If this was more than 1 or less than -1, it would have been, so we're good there. So this part we're fine with, but cast rule is what you said, right? So it was sine, it's negative. That means we are in quadrants 3 and 4. So now I go plus pi and then 2 pi minus. And so x equals, just watch on the calculator, I'm going to take this value and add pi. Okay, that looks good. And then I'm going to actually, this is again, we talked about this before. This is just calculator tricks. Now I'm going to subtract pi to get back to the theta related, because that's a quick way of doing it. And then I'll do 2 pi minus. And using your calculator is a little bit tricky with doing these, but you know, a little bit of practice is not that hard. And we're not done. Again, I'll point out how different this feels. I'll also remind you, we talked about this yesterday. You have to know when you can get exact value and when you can't. And when you can't, it's rounding to 4 decimal places or whatever the test says, which is generally 4. But you got to follow those directions. So be careful of that.
Is there a reason why it's positive 6, or was that just a mistake? Or is it supposed to be
Positive 6. That should be positive. Yeah.
Oh, I forgot you're adding 2 pi?
No, it's 2 pi minus, but it's 2 pi minus a small value.
Oh.
Your answers should be between 0 and 2 pi, so they should be positive, for sure. Okay, do you want to try this one? Now, this one's already positive, so it's a little bit easier. Oh, the other thing I meant to say, the reason why I do this, like I add pi and then subtract pi, is otherwise I'd have to go back all the way here and put that back in. If you're really good with your calculator and the memory functions, it might not be that bad. Again, that's kind of up to you. It's a little bit finicky, but you know, that's just how it works. So again, you just have to practice a little bit. Okay, give the next one a try. And I got those two. Questions? Okay, one more. What do you notice about this one?
It has both sine and cos.
It's got sine and cos, therefore, yeah, we gotta do a swap out. We also have to move the sine or the coses or whatever, everything to one side. You always have to get everything equal to 0 for these ones, right? The only kind that you don't do that is where you isolate when it's like linear. Okay, so I'm gonna move the 2 sine squared x to the other side, and we'll see why in a minute. This part really doesn't matter which direction you go. It's a really small detail, but some people like looking out for this kind of stuff. When I swap out the sine squared, I got to put it in brackets because the whole thing is times -2. Okay, now I'm going to expand, simplify, put everything together, get it in the right kind of format, ready to go for either factoring. This is going to be a trinomial again, either factoring or quadratic formula. So I got -2 plus 2 cos squared x. Okay, and I'm going to go through this one a bit more quickly. Looks like we get 124 for that one. So again, not factorable. So the little thing that I did here was I knew that like this, the sine squared term is a negative coefficient, but when I swap it out, that's also negative. It's minus cos squared. So it makes it positive, which is what we want. Like you want that leading coefficient to be positive for factoring or whatever, right? So, but if that didn't happen, if you didn't pay attention to that and you ended up with a negative, just flip all the signs, obviously, right? It's not that big a deal, but you want to be aware of those little things that you probably got really good at back in units 1 and 2 when we were factoring and doing all this kind of stuff, and in unit 2 in particular when we started doing quadratic formula and solving. You're probably really good at it. It feels different when it's trig. It just does, right? It's a little bit harder, so you want to be that much more careful. Just remind yourself of all those little tricks. All right, so then we get cos x equals -10 plus minus root 124 over 4. And in this case, I'm not going to, I think that probably could reduce. Yeah, but I'm not going to bother. Oh, I meant to split it up first. Okay, so what?
No solution.
For the first one, right?
Yeah.
So this, again, is the other reason why we want to get that decimal value and see if it's outside the range of cos or sine or whatever you're working with. And so this one is no solution. Kind of nice. It shows your understanding. It shows that you're being careful in doing all the steps, but it also saves you a little bit of work. You don't have to do it twice, right? You only have to go through and do everything once. So x related in this case works out to 1.2830, and it's positive. So quadrant 1 and quadrant 4. And that's that. Again, I can't stress it enough. Don't take it for granted. There are these little steps in the quadratic formula with trig equations that you have to be just really, really careful of. Watching for negatives, watching for no solutions. I could imagine what would happen if you didn't get the decimal value and you just did shift cos of that. What would your calculator do? Oh. Try it. Anybody? Anybody? Explode? It would explode. Yeah, it won't actually explode, but it'll give you an error. Yeah, right? Because there's no solution. So it will give you an error. This is not solvable. This part over here on the left. Not solvable. It'll give you an error. What if you're on a test and you're trucking along, you're like, I'm doing great, I got this, and all of a sudden your calculator gives you an error and you're like, oh my gosh, I'm the dumbest person in the world, I don't know what I'm doing. That's where our head goes sometimes. Doesn't it? Isn't it weird? You have this panic. You're like, oh my gosh, I thought I knew what I was doing. Why am I getting an error? Oh, maybe I just did something wrong. I'll try it again. Error again. Okay, I'll try it again. Error again. And then you start looking for mistakes. No, it's just because when you look at this negative 10 minus root 124 over 4, you can't tell what size that is. Is it bigger or smaller than negative 1? So get your decimal version. Include that as one of your steps in doing these. Use that to tell if it's negative for quadrants and for putting it in your calculator, and if there's a solution or not, because otherwise you will get an error and you might panic a little bit.